Okay, stream is up. Should pop out chat or something in case that becomes useful. Okay. Oh, I should put this guy's video in the description. Go. Okay. Uh, all right, I was putting a link to this guy's video in the description. Okay. So link there. Um, description. Yeah, I don't know how to edit the description. Manage? No. There we go. Okay. Link to tutorial. There we go. Okay. Trying to find a good place to put chat. I guess over here is fine. Alrighty. I didn't even spell that right. Whatever. In the folder. Oh yeah. Today I learned you can highlight things in command prompt. Okay, cool. Okay. Hmm. I'm excited. Drawing a shape. Okay. I don't know. Oh, you guys can't hear the audio from that. Hold on. Audio output. Existing. It'll be new. It'll be audio.
Talk generally about what programs are and how we can write them. And we're going to write a little program which is going to print out a shape
There we
over
go.
the screen. So this is going to be pretty fun. Down here, I just have this basic program. And when I first created my C++ project in the last tutorial, we sort of got this basic program. And this was kind of given to us. And this is, essentially just a very simple C++ program. So I'm going to walk you guys through essentially what we have here. We're going to talk about a couple different things, and then we'll start writing some code. So up here, we have these two lines of code. This is like hashtag include IOStream, and this one says using namescape std. Essentially, what this does is it's kind of like configuration options for our C++ file. As a beginner, don't really worry too much about what this stuff is or what it's doing. We're going to talk more about all of this stuff later in the course, but for now, just know that you need to have it there in order for us to write our programs. Down here, we have this line. It says int main, and there's an open and close parentheses. This is actually what's called a function in C++. Again, don't worry too much about what a function is. I'm just kind of throwing out these words just so you're kind of familiar with hearing them. But essentially what this is it's a container for us to put the code inside of our C++ programs. So this function called main is a very special function because any lines of code that we put inside of here, in other words, any lines of code that we put in between these open and closed curly brackets, is actually going to get executed when we run our program. So down here, I just have this thing. It says return 0. And again, don't worry too much about what this is. Just know that you need to have this in this main function. Over here, though, we have an actual line of code. So this says cout, and then it says hello world, then it says end L. And this is a basic line of code in our program. So again, any lines of code that we put in between these curly brackets for this main function is going to get executed when we run our program. So if I was to come up here and run my program, and I'm just going to click this build and run option right here, you'll see when the program runs, it prints out hello world. And you'll see this little window that opened up here. This is what we would call the console. And the console is basically just a little window that will output information.
Okay, this is like a 4-hour video. I have to play it on a faster speed. do 1.5.
So whenever we run our C++ code, this console window is going to open up. And sometimes we can tell C++ that we want to print things out onto this console window. So if you ever hear me referring to the console, I'm just referring to this window right here. Now let's get down and start talking about programming. So again, any of the code inside this main function is going to get executed. And here we just have one line of code. So what I could actually do is I could copy this, and down below here I could say something else. So I could say just like my name, Mike. And now when I run this program, you'll see it's going to print out both of these things. So here on the first line, it prints out hello world. And then over here on the second line, it prints out Mike. And this is just sort of like basically how we could print something out to the console. You'll see over here it says C out, and that stands for console out. And then over here, you'll see we have this little line. It says end L, and this stands for end line. And basically, what this means is we're ending the line where we're going to print out text. So you'll notice that we printed out hello world, and then on the next line, we printed out Mike. So using these little print statements, I'm actually going to show you guys how we can write a little program that's going to draw a shape out onto the screen. So I'm actually going to go ahead and get rid of this text, and I'm just going to copy this guy here a couple times. So we'll make like 4 of these, and I'm going to print out a triangle onto the screen. So I'm just going to print a /.
Okay, so gets rid of the text in the brackets, and then he copies the line. Did 4. Bottom one will do a //.
And then we'll do a space and a // and I'm just going to keep doing this, and you'll see we're kind of drawing this little diagonal.
Okay.
Shape upwards. Now I'm going to use vertical bars, and we're going to go all the way down. So I'm just going to keep going like this. And down here, why don't we put some underscores, and then we'll put the last vertical bar.
Okay. Oh, he wanted to do underscores. Cool.
So you'll see over here, I'm actually writing out a bunch of instructions. And each of these instructions is telling C++ that we want to print out a different line onto the console. So now when I run my program, you'll see we're actually printing out this little triangle. So this is a very basic program, but you'll see just by using those 4 simple instructions, we were able to actually draw something out onto the screen. So let's talk about this. Essentially what's happening when we click that run button is C++ is going and it's looking inside of our program. And the first thing it's going to do is it's going to look for this main function right here. So it's going to look for this block of code, and that's basically just what a function is. It's going to look for this block of code called main, and inside of these open and closed curly brackets, it's going to execute all of the instructions inside of there. And basically when we're writing a program, all we're doing is we're just telling the computer a bunch of instructions. So we're giving the computer a bunch of instructions that we want it to carry out. So imagine that, for example, in real life, like you were using a recipe or something. A recipe is a lot like a program. A recipe has a list of instructions, and if you follow those instructions correctly, then you end up with like something delicious. That's basically what a program is. A program is just a collection of instructions that we're giving to the computer. And we can give the computer simple instructions like this, and we can do something simple like draw out a shape. But as we go through this course and we learn more and more complex instructions, and we learn how to use them together in unison with each other, we're going to be able to tell the computer to do a bunch of complex things. So the next thing I want to talk to you guys about is the order that these instructions get executed. So just like if you were following a recipe and you would start with the first instruction and you'd go down to the last instruction, the computer is going to execute these instructions in order. So it's going to start with this instruction, and basically here we're just telling the computer, or we're telling C++ that we want to print this line of text out onto the screen. So C++ is going to do this, and then once it's done with that, it's going to move on to this instruction. It's going to print this out onto the screen, etc. It's going to keep doing that. So actually, let me show you guys. If I was to get rid of this line, and I was to put it up here, now you'll see when we run our program that we're going to print out a funky looking shape. So instead of this base being down at the bottom here, we're going to print it out on the top. And that's because we changed the order of the instructions. So again, all a program is it's just a set of instructions that we give to the computer. That's it. It's very simple. The more complex instructions that we can give the computer, and the more ways that we're able to combine those instructions in different ways, the more complex our programs are going to be. So as we go through this course, I'm going to be teaching you guys all sorts of more complex instructions. We're going to learn different ways to do different things, and we'll use real-world examples to build little applications, and you'll end up learning a bunch along the way.
Variable.
In this tutorial, I'm going to talk to you guys about using variables in C++. Now, a lot of times when we're writing programs in C++, we're going to be dealing with all different types of data and information. And a lot of times when we're dealing with that data and information, it can be kind of hard to keep track of. And a variable is basically just a container where we can store different pieces of information or different data values in our programs, and it makes it a lot easier for us to manage and maintain and use that data. So I'm going to show you guys an example, and I'll show you guys basically how variables are useful and how we can use them in C++. So down here, I have a very basic program that I've written out. You'll see down here, I'm basically just printing out a bunch of lines of text. It says, there once was a man named George. He was 70 years old. He liked the name George, but did not like being 70. So this is basically like my little story here. And you'll see I can run my program, and this is a valid program in C++. It basically just prints out the story, and we have all of our information. So, this is a pretty nice C++ program. It serves its purposes. But let's say that I'm looking at my story, and I'm thinking, maybe I want to change the character's name, right? So maybe I don't like the name George. Maybe I want to change it to a different name. So what I could do is I could go through and I could manually change it in each line of code. So I could come here where it says George, and I could change it. Let's say we want to change the character's name to John, right? So I can change it to John. I'll keep looking through the story. Down here it also says George, so I'll change it to John. And there we go. We've changed the character's name. We've officially updated it. Let's say maybe now I'm thinking to myself, I think I want to make the character a little bit younger. Instead of 70, why don't we make John 35? So I can do the same thing. I can go in and manually change the value of 70 to 35. So we can come over here and we can say he was 70. We'll change this to 35. And we'll say did not like being 70. Okay, so we'll change that to 35 as well. So now we've officially updated our story. We've changed the character's name and we've changed the character's age. Here's the problem though. In order to make those changes, I had to manually go through and individually edit each one of the places where the character's name showed up or the character's age showed up. And imagine that instead of having a story that was only 4 lines long, I had a story that was like hundreds of lines. And we mentioned the character's name hundreds of times, and we mentioned their age hundreds of times. Well, all of a sudden, it becomes a lot more difficult for me to manage those pieces of information. So it's difficult for me to manage the character's name and the character's age. Right? Okay. If I had a story that was hundreds of lines long, and we mentioned the character's name 100 times, having to go and modify and update that name would be a very tedious task because I'd have to go through and essentially just do it manually.
That's a good analogy. That it's like a storybook character or like something along those lines. It's a pretty good analogy.
This is where something like variables come in. A lot of times in our programs, we're going to have different pieces of information, different data values that we want to keep track of and we want to be able to manage. So what we can do is we can take those pieces of information and we can put them inside of containers called variables. And a variable, like I said, it's just a container where we can store a piece of data and it'll make it a lot easier for us to use and manage that piece of data in our programs. So I'm going to show you guys how we could create a variable that could store the character's name and the character's age, and you'll see why this can be useful in something like this. So over here, I'm going to create a couple of variables. When we create a variable in C++, we actually have to tell C++ a couple of things. The first thing we have to tell C++ is what type of information we want to store inside of the variable. Now, in the next video, I'm going to talk to you guys all about the different types of data that we can use in C++. But for now, I'm just going to show you guys 2 types of data. The first type of data that we can store inside of a variable is called a string. And that basically means it's a string of characters. So it's like plain text. So this down here where it's saying there once was a man named John, this is a string, right? It's plain text in our program. A lot of times we're going to be dealing with strings. So I'm going to create a string variable. In other words, I'm going to create a container that can store a string value. So I'm just going to say string, and that's the first thing that we have to tell C++. The next thing we have to do is give this container, give this variable a name. So what we want to do is give this a descriptive name, which will basically tell us what is inside of the variable. So I'm just going to call this character name, just like that. And what I can do now is I can give this a value. So I could say character name is equal to, and now we can type in the character's name. So I could say John, just like that. All right, so once we've created this character name value variable, now this value, John, this string value is now stored.
Let's pause it. John. Okay. Oh, and then he ends with a colon. Okay. Probably to denote the end of the line or something.
Inside of this character name variable. The next thing we're going to do is create another variable to store the character's age. In addition to storing data in the form of a string, we can also store numbers. Now, age is a whole number. So what I can do is I can store it inside of something called an integer. And an integer is basically just a whole number. So I could just say int, and I can just call this character age. Now, I want to show you guys another thing that we can do. So up here, what we did is we said string character name, and we set it equal to a value right away. But what I could also do is put a semicolon here. And also, I do want to point out, whenever we're writing lines of code in C++, every time you finish writing a line of code, you want to put in this semicolon. I'm not sure if I mentioned that in the last video, but the semicolon basically tells C that we're done with that line of code. So this separates one line of code from another. So you need to always make sure you put these semicolons. But with a variable, what I could do is I could say int character name. I could do the same thing for string. And then I could go on to a new line and I could give this a value. So I could say like character age is equal to, and now I'm just going to type in a number. So we said that John was going to be equal to 35. And you'll notice when we use numbers, we don't have to surround these with quotation marks. We just can type out the number.
Wait,
so now we have
hold on.
variables.
How do I auto-complete that line? That seems like that'll be important. Not shift. Enter. Okay. Equals 35. Semicolon.
And I showed you 2 different ways that we can create them.
Okay.
And what we can do is we can use these variables inside of our story, and you'll see how this makes it a lot easier for us to maintain this program. So what we want to do is we want to replace every instance of the character's name and the character's age with the variable. So instead of just printing out John here, I want to refer to this variable. And the way that we need to do that is we basically need to include this variable. So over here, I'm printing out this string of text. I'm printing out a bunch of plain text, right? But let's say instead of just printing out John here as plain text, I wanted to instead print out the value that was stored inside of the character name variable. What I can do is I can just get rid of John, and I can say less than sign, And what this is basically going to tell C++ is that we want to take the value that we're going to type out here. So I'm just going to type out character name. And it's basically telling C++ that we want to take this value and we want to insert it right here inside of this line of text. So when I go ahead and run my program now, you'll see that we're still printing out there once was a man named John, except now I didn't actually type out John. All I did was include this variable right here. And I basically just said that we'll put the variable right in there.
I typed names.
That's how we can include a variable inside of one of these print.
Wow, it's not going well that I'm already making typos. What happens if I delete the space? Hello? Oh, it's because I still have the console open, maybe? Yeah. Let's try it again. Okay, there's no space, so it accounts for the space. Here. Okay. He has a space. I don't know how relevant spaces are. Maybe it's just more readable.
Here I'm going to do the same thing, so I'm just going to say less than character
John.
name.
Okay, so I'll go through this then and mess with it. Character name, and then 35 space brackets character age. I keep forgetting to close this window. There once was a man named John. 35. Oh yeah, I have to adjust the 35 over there as well. I don't know how to do it in the middle of the line of text. So
and now this is going to insert the character name. In other words, it's going to insert the value stored inside of the character name variable at this position. We can do the same for the age. So over here we have the character's age. I'm going to get rid of that, and I'm going to say less than, and now character age. And so the value inside the character age variable is going to get placed right in there. And we have one more place where we have the character's age. So over here, I'm going to get rid of this. And now this is going to be special. So you'll see over here, we want to insert the value inside of the character age variable right in between all of this text. So I want to put it right here. What I can do is I can make 2 quotation marks. And essentially what this is doing is it's saying this is going to be its own string of text, and this is going to be its own string of text. And I can make 2 less than signs. I can type out the character age variable. And then I'm going to make 2 more less than signs. And this is essentially just going to string all of these.
Why did
together.
it
So
not complete? Oh, it was too close to the quotes, I think. Yep. Character age, and then 2 more less than signs. Yeah. Okay.
Print out this text, then print out the value inside of the character age variable, then print out this text. So I've now replaced every instance of the character's age and every instance of the character's name with those variables. Let's run our program and see what happens. Over here, you'll see we have the same exact story as we did before. There once was a man named John. He was 35 years old. John, 35. So without having to manually do anything, we were able to include those values. And now what's cool about variables is if I wanted to update the character's name or update the character's age, all I have to do is change it up here in one spot. So if I wanted to change the character's name to Tom, and I wanted to make Tom, let's say 50 years old, I only have to modify the values that are getting stored in the variables, and they'll automatically update down in our story. So now when I run my program, you'll see it's using the name Tom, and it's saying that he's 50 years old. So that's kind of an awesome way that we can use these variables. Another cool thing that these variables allow us to do is modify the value. So let's say that halfway through our story, I wanted to change the character's name. Right, so halfway through, I wanted to make the name be a different name. All I have to do is say character name, and I can actually assign this a different value. So I could give this a value of Mike, and again, I'm going to need a semicolon here at the end of this line of code. And now you'll see halfway through the story.
Okay. Character name. Mike is a good name. That's my name. And a semicolon. And then run it. Oh, and you know what? Let's do int character age. Do I have to do string again?
The characters, again, I'm going to need a semicolon here at the end of this line of code. And now you'll see.
You didn't write string again. Okay. Maybe because he already designated character age as a string. Or character name as a string. Or an integer, whatever all that stuff is. Let's say he's 90. Mike is 90. Yikes. And then a semicolon. Build. Oh yeah, see, it broke, so he probably didn't do it right either.
The character's name is going to change. So it says there once was a man named.
Why did it break? Why is this red? If I write string. All right, well, I messed this up somehow. So let's go back and watch it. Build it. Okay. Hit enter.
Tom, and down here it's using the name Mike. So not only was I able to just use those variables to insert these values, but I can actually modify those variables at different places in my program. So that's
Oh, I needed to put it in quotes. Okay. Character name equals quotes Mike. Character age equals, and this one's an integer, so I don't have to, 90. And then, oh, I didn't put a semicolon here. Let's try it. Once was a man named Kane. He was 50. He liked the name Mike, but he did not like being 90. Cool.
pretty awesome. Now, this is just sort of like the bare basics of variables. Variables are containers. They allow us to
I want to put a note here. I think I know how to make notes. Strings of text require quotations. Make sure that doesn't run. Maybe it's only one hashtag. Okay, I don't know how to make notes then in C+ yet. That's fine.
maintain and keep track of the data and the values in our programs a lot better. And they also give us the advantage of only having to assign a value once. So I can assign a value once up here, and then I can use it and refer to it at different places down here. I can also modify those values at different places in my programs. So in this tutorial, we talked about storing values as strings of text and as integers, which are whole numbers. In the next tutorial, I'm going to show you guys all of the different types of information and the different types of variables that we can create in our programs.
Data types.
In this tutorial, I'm going to talk to you guys about the different data types in C++. Now, a data type basically just means a type of data or a type of information that we can use and work with inside of our C++ programs. So there's all different types of information we can store, like text, different types of numbers, decimal numbers, true, false values, all sorts of stuff. And I'm going to kind of walk you guys through what all of those are and how we can use them. So the easiest way for me to demonstrate this is just going to be to create a bunch of different variables. So any of the different types of data that we can work with in C++, we can actually store inside of variables. So I'm just going to create a couple different variables, and I'll kind of show you guys exactly.
Okay, so I want to save this. We'll do a new project, console application. Just so that I can keep these separated, I want to keep, like, I don't want to just delete the lines of code and then have to go back to the video. Okay, so, ooh, did I really name that Lurgan? Oops. There we go. I don't think I spelled giraffe right either. Okay, let's rename this. First lessons. I think lessons is just an E. Okay, first lessons is what I named that. That one. Okay, so learning. And then it'll be in this folder, and the title will be what did he call this? Data types?
Exactly how this is. Really store, I'm going to walk you guys of type of you guys about that we can create whole numbers. In the next tutorial, I'm going to show you guys all of the different types of information and the different types of variables that we can create in our programs.
Data types, yeah. Okay, so that's what we're doing here. Oops. No to close it. Well, if it deleted it, whatever. Data types. Next. parse. Okay, so I have to go back and rename that. So let's just go there real quick. Terabyte. Where is it? Code blocks. Learning. So first lessons, I named this that. Then I want to name it back to my poor misspelling of giraffe. Continue. Let's see if we can open it. Oh, because I changed learning too. Fuck it. I'll just delete it. It's fine. Remove. Close project. No. I don't care. Okay. We're back to a blank one.
I want to talk to you guys about the different data types and data that we can work with in C++.
Okay, so let me copy this out before he goes any further. He's got a bunch of space, a lot of space. And that's it. Okay.
We can actually store inside of variables. So I'm just going to create a couple different variables and I'll kind of show you guys exactly how this is going to work. So the first data type I want to talk to you guys about is called a character. And a character basically allows us to represent one single character. So the way we can create a character variable is just by saying char. And now I want to give this a name. So let's just call it like grade or something. And whenever we create a character, we're going to use these single quotation marks. So I can store any like regular character that I would want inside of here. So, you know, essentially any character that you can think of, you could store in here, and then we're going to include this semicolon. So that's basically like the character data type. And in addition to just storing one single character, there's going to be a lot of situations where we're going to want to store like more than one. And what we can actually do is use something called a string. And a string is basically just a string of characters. So it's instead of just being one single character, it's like a bunch of different characters. So this would be like essentially just plain text that we would see in a program. So I could just say string, and we could just call this like phrase. And when I create a string, I can use these double quotation marks. So I could say like Giraffe Academy or something. And now we're going to be able to store, instead of just one character, a bunch of different characters. So there's different situations where you might want to use either like a char or a string. But for the most part, I think strings are probably a little bit more commonly used than chars. So instead of just plain text, we can also store and work with numbers. So essentially there's two different types of numbers, two basic types of numbers. There's whole numbers and then there's decimal numbers. Some people also call those floating point numbers. A whole number is like a counting number. So think like 1, 2, 3, 4, 5, right? They're just whole numbers, solid numbers. There's no decimal points, right? Then we have decimal numbers. So it'd be like 0.5 or 1.267 or 10.11. You know, basically a number that has a decimal point after it. When we work with these different numbers, C++ is actually going to distinguish between them. So the first type of number we can work with is an integer. So I can just say int, and this could be like an age or something. So whenever we're creating a number, we can just type out the number. So I could say like 50. And you'll notice I don't need any quotation marks. I don't need anything special surrounding this. I can just type out the number. In addition to positive numbers, you can also use negative numbers. But anytime we're using an integer, you can't have a decimal point. So you can't do anything with decimals. These are just going to be solid whole numbers. If you want to work with a decimal, you have two basic options. So there's two data types that represent decimals in our programs. The first is called float. And this basically just stands for like floating point number. The second one is called double. Now, you'll hear different people talk about these different data types. The main difference is just how many decimal points they can store. So a double can store more decimal points than a float. So if you need a number to be very specific as far as like how many decimal points you can take it to, then you definitely want to use a double. And I would say for the most part as a beginner, just only worry about doubles. Floats will be used more in specific circumstances, but you know, as you're just learning this language, really just worry about doubles. So we could just say double like GPA, and I could set this equal to like 4.5 or like 2.3. Basically, I can make this any decimal number that I want.
Well, it's set it to be accurate, right? I have no idea what my GPA is. It's probably really shitty. It's like 2.0 or 1. Let's see, 1.7, 1.9. I have no idea.
Keep in mind, you could also do like 2.0, so it doesn't have to be like a different number decimal. And again, you can make these negative. That's no problem. So ints are going to be what we're going to use for whole numbers. For the most part, doubles are going to be what we're going to use for decimal numbers. So that covers text and numbers. And just with those two data types, with text, we can use characters and strings, and then ints and doubles. You can represent like just about any type of information in your programs. But C++ is awesome, so they're actually going to give us another data type, which is called a Boolean. And a Boolean is maybe not as intuitive.
Okay. I actually enjoy Booleans. It's like 0, 1, true, false.
As
like those.
Like text and numbers. A Boolean is actually what we would call a true false value. So when we're writing our programs, there's actually going to be a lot of situations and circumstances.
I always thought they were pronounced Boolean.
A Boolean. And a Boolean is just a special word for true or false. right? So I could say
Interesting.
bool, that stands for Boolean, and we could create a variable like is male, right? So this variable is male is going to store a true or a false value inside of it, and this will basically tell us whether or not someone is male. So in my case, I could say true because I am a male, right? So you'll see how this can kind of come in handy for different things. Like we could say something is true or we could say something is false, and that allows.
Oh, here's something I want to test before he moves on. If I type out the value for a Boolean as true, do I have to hit enter or can I just hit, okay, I can just hit semicolon. Because I was typing it out and then pressing enter to like auto complete the recommendation. And then semicolon, but I don't have to. I can just type true. I don't have to press enter because it doesn't do anything. It confirms that it's what I want to type, but like I'm already there. So what if I'm not all the way there? So if I hit, then I can finish it with typing the E. That seems like a waste of time though.
Allows us to represent a certain type of information. I could also say false over here.
You guys ever have those moments where letters don't make sense in words for you? I don't know if that's just me. That's probably just me. But like looking at the letters of true, like I can read it and see true, but I also see TRUE and I'm like, that doesn't look like a word. Anyway,
it's going to be the opposite. So these are going to come in handy a lot, these true false values, and we can use Booleans to represent them. So for the most part, these are the basic data types. Now there's a couple other data types that we could also get into, but I think 99% of the time as a beginner, as somebody who's learning C++, don't concern yourself with anything that you don't have to. So Booleans, doubles, which are just decimal numbers, ints, which are whole numbers, strings, which is plain text, and chars, which are just single characters. That's what we're going to be working with. So as we go forward in the course, we're going to be working with all this different type of information. Now, I want to point out one more thing. So I'm actually just going to make a little print statement here. And this is a basic statement. So if I wanted to, I could print out any one of these variables. Like if I could print out grade, for example, and this is going to go ahead and print that out onto the screen. You see over here, we're just printing out A. But we don't have to store this information inside of variables. So if I wanted, I could just type in a string down here, right? I don't have to store it in a variable. This is what we would call a constant. So I don't need to store it inside of a variable. I could also, type out like false, or I could type out a number like 4.5, or I could type out an integer, or I could type out a character. Like you don't have to put these things inside of variables. A lot of times you can just use them like straight up like that. And this is what we would call a constant. But a lot of times you're going to want to store information in variables because it's really useful. And obviously when you do that, you have to declare the data type and you have to tell C++.
Okay. Hold on, let me pull up. So this was, I was going through and taking notes on a couple of things that I was reading because the end goal with this was learning to program for video games. But anyway, let me see if I can find out what he was just talking about. They said not to use constants. Static avoidance. Avoid static variables. Okay. I don't really know what that means, but it sounded like something he said.
Just use like straight up like that. And this is what we would call a constant. But a lot of times you're going to want to store information in variables.
It's not static.
It's really useful. And obviously when you do that,
those are similar words, so I just assumed that they'd be kind of similar, but we'll continue.
What type of data you want to work with.
Oh, I wanted to see what happens if I run this. Does it even do anything? Types A. Okay, because it's whatever C out means. And then it's running grade, which is the character, and the character is A. Okay.
And this
is there a way to, there's probably a way to make another one of these. New class? No, that's not right. I guess project. Okay, this one will be called.
Tutorial, I'm going to talk to you guys about what type of data because it's really useful. And obviously when you do that, you have to declare the data type and you have to tell C++ what type of data you want to work with.
Working with strings. Okay. Wow, working with strings. Finish. Okay. Can I rename this? Probably not. It's fine. I know where it is, so.
In this tutorial, I'm going to talk to you guys about the ins and outs of
Oops.
working with strings in C++. And the C++
Okay.
programming language, one of the most common types of data that you're going to be working with are going to be strings. And strings are basically just plain text. So any type of plain text that we want to represent or work with in our program is going to be considered a string. So down here, you'll see I have this little program set up, basically just printing out a couple lines. So the way I can create a string is just by using an open and closed quotation marks like this. So I can basically type out whatever I want. If I wanted to, I could type out Draft Academy. You'll see now I'm printing out Draft Academy and hello. If I was to run my program, you'll see that we print out Draft Academy and hello. First thing I want to show you guys is has to do with this C out line of code over here. So you'll notice here it says end L right here. And basically when we put end L right there, it tells C++ that we want to print a new line after we print whatever is in here. So if I was to get rid of this and I just said C out Draft Academy, now what you'll see is that hello.
Okay, so let me put something in here. Should we write? Those are red. Hooray. Okay. So if we run this, it should be 2 lines. Roses are red and hello. Okay. Any key to continue. Oops. And then if we get rid of this up to the semicolon, yeah. And then we run it, it'll be roses are red, no space, hello. What happens if we put a space here? Okay, cool. So that, but we can do double, I don't even know what to call those things. And then end L.
Hello is going to get printed on the same line as Draft Academy because we didn't put end L, so we didn't put a new line. If I wanted to, though, I could actually manually come in here and specify a new line by saying \n. So \n basically means that we want to print out a new line. So this inside of a string represents the new line character. So now when I run this program, you'll see that hello gets printed out on a new line. So that's how we can use that \n inside of our string in order to do essentially the same thing as end L is doing. And if I wanted,
/n. Oh, okay. It's like enter. \n is like the computer equivalent of pressing enter. Okay, cool.
I could put this like in between these two words and it would put them on a new line. So in addition to just printing out a string like we did over here, I could also store a string inside of a variable. So in order to create a string variable, I can just say string. We'll give it a name, so we can just call this phrase, and I can set it equal to.
What did he just say? That totally went over my head.
String in order to do essentially the same thing as end L is doing. And if I wanted, I could put this like in between these two words and it would put them on a new line. So in addition to just printing out a string like we did over here, I could also store a string inside of a variable. So in order to create a string variable, I can just say string.
So he wants to store a string variable. String?
We'll give it a name, so we can just call this phrase, and I can set it equal to whatever I want. So
okay. Phrase equal to roses are red.
let's set it equal to Draft Academy. And then I can do exactly what I did
then
down here. So
the
here
colon.
I print out.
Okay, and then we can delete this like he's saying. And we can just write phrase. Let's run it. Roses are red, no space, hello. Okay, cool.
Phrase, and now it'll be printing out Draft Academy onto the screen, just like that. So in addition to just printing out strings and kind of working with them now.
Okay, hold on. What if I do \n here? What does that do? Nothing, it doesn't work. Okay, so for the phrase, for the string to work, it's gotta be end L colon. Yeah, Okay, cool.
that way storing them inside of variables. We can also use what's called string functions. Now, a function is something that we're going to get into more later in the course. We're going to write our own functions, but for now, just know that a function is basically like a little block of code that we can call, which will perform a specific task for us. So these functions do all sorts of things, and there's a lot of functions that we can use with these strings, and they're called string functions. So these functions will either like modify the string, or they'll give us information about the string. So I'm going to show you guys a couple. So the first string function that I want to show you guys is the length function, and all I have to do to use this is I can just come down here, and
Okay, so he got rid of the other line. Let's follow along. I don't want to get too far out of place with like exactly what he has typed out. He doesn't have endl.
Actually just going to print out the result of using these functions, so I'm going to put it down here. I can just say phrase.length, and I can make an open and close parentheses. And generally when we're
Okay. Phrase.length. Hold on. Let's delete that. Let's retype this. Phrase.length. I don't think he has a space. And then he has the colon.
calling a function in C, we're going to use this dot, and then we're going to type the name of the function. So this is the length function, and we're going to make an open and close parentheses like that. So now if I was to run this program, you'll see we're getting 15. So this is basically just telling us how many characters are inside of this phrase string. So how many characters are inside Draft Academy?
Oh, cool. Okay. So phrase length 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, cool. So it's saying the length of phrase is 13 characters. Cool.
Now, if I wanted to, I could actually access individual characters inside of here. So let's say that I wanted to access just this G. So I wanted to print out the first character in this string. Well, I can make an open and closed square brackets just like this. And inside of here, I can put a 0. And 0 is going to refer to this first character in the string. So now when I run my program, you'll see we're just printing out this capital G. If I wanted to access this R, for example, I could say 2. And 2 is going to refer to this R. So now when I run my program,
okay, so so the numbers start at 0 here. So if I do 5, it should be S. Wait, what did I do wrong?
As you can see over here. So if you haven't caught on yet,
Wait a minute. Oh, he did brackets. He switched to brackets. Hold on. I'm already not paying attention. I'm reaching the end of my day's learning, and we're only like 16 minutes in, or whatever, 42 minutes, but at 1.5 speed. What is that? 28 or something like that. Time to math. Oh my god, it's exactly 28. I'm a genius. I'm a genius.
Wanted to, I could actually access individual characters inside of here. So let's say that I wanted to access just this G.
So he gets rid of dot length and the parentheses. So let's do that.
So I wanted to print out the first character in this string. Well, I can make an open and closed square brackets just like this. And inside of here, I can put a 0. And 0 is going to refer to this first character in the string. So now when I run my program, you'll see we're just printing out this.
So we're doing
if I wanted to access
brackets like
this
this.
R, for example,
So I wanted to do 5 for S.
And 2 is going to refer to this R. So now when I run my program, we're printing out R, as you can see over here. So if you haven't caught on yet, whenever we're indexing a string, we're starting at 0. So if I was to assign index positions to each one of these characters in the string, I would say that G is at index.
How did I mess it up? How do you do that?
Position 0, we're printing out R. As you say, 2, you'll see we're just printing out this 0 and character in this individual characters inside of here. So let's say that I wanted to access just this G. So I wanted to print out the first character in this string. Well, I can make an open and closed square brackets just like this. And inside of here, I can put a 0. And
now it's R. Now it's returning R. Okay, so 5. Oh, I'm already dumb. This is 0, so 5 is the space. Okay, so if I wanted S, it has to be 4. Yep. Okay, what about 8? So this is 5, 6, 7, 8 should be an E. Yeah. Okay, cool. And what if it's a number that's bigger than the whole number? So I think it was 13 characters long. So what if I do 14? Returns nothing. Okay.
And 0 is going to refer to this first character in the string. So now when I run my program, you'll see we're just printing out this capital G. If I wanted to access this R, for example, I could say 2, and 2 is going to refer to this R. So now when I run my program, we're printing out R, as you can see over here. So if you haven't caught on yet, whenever we're indexing a string, we're starting at 0. So if I was to assign index positions to each one of these characters in the string,
He's
I
using
would say
tab.
that G is at index position 0, I is at index.
So I want to mess around with this. Yeah, he's using tab. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc.
Index position 1, R is at index position 2, A3, F4, etc. So whenever C++ is indexing a string, it always starts indexing it at 0. So it'll start counting basically 0, 1,
Can I make the text bigger? Oh, I can zoom in. Hold on. Wait a minute. No, I can't. I would like to zoom in. How do I zoom in? Like that. Just like I do in every other program. Oh shit. What did I do? Okay, I just scrolled.
2, 3, 4. Even though G is the first character in Draft Academy, it's technically at index position 0. So whenever we're using something like this, we're referring to like a specific character, we want to refer to the index position, which is going to start at 0. Another thing I could do is I could actually like modify a specific character in a string. So I could say like phrase, and I can refer to an individual character inside of this string. So we could say like phrase 0. I could assign this a new value. So I can assign this the value of a new character. So you'll notice I'm using these single quotes. So I could say like B. And so now, instead of saying GIRAFFE, it's going to say BIRAFFE because I'm essentially changing one of the.
Okay. Let's get rid of these brackets like he did. Phrase, string. And then we want brackets. Eight, 9, 10. I want 10 to be equal to single quotation B. Run. Oh yeah, this is nothing. Phrase 10 equals B. Oh, I need a colon. Roses are bad. Roses are bad, dude.
Characters in this string. So now when we print this out, you'll see it says Giraffe Academy instead of Giraffe Academy. So that can be kind of handy just to modify a specific character inside of a string. We could also find out information about this string. So I showed you guys how we can find out the length of the string, but imagine if we wanted to find out whether or not a specific string or a specific character was inside of this string. I could say phrase.find, and I can make an open and close parentheses.
Phrase.find. And then open close parentheses. There's got to be a better way to do that. Let me mess around. Open parentheses, enter. No. That did not work. Maybe it just completes automatically if I do phrase open and then type something. Because I know if I do like red and then hit enter, it's going to do that thing. I don't think Control Z works how I want it to. Jump back, yeah. Oh yikes. Let's not do that.
And actually, inside of these open and close parentheses, I'm going to give this find function a couple different pieces of information. So I'm going to give it some information for it to perform its task with. And these are called parameters. So anytime I give a function different pieces of information, we call it passing parameters, or you also hear people call them arguments. So passing arguments or passing parameters. Basically, it's just information that we give to this function. So this find function, I need to give a couple pieces of information. The first thing I can do is give it a string or a character that I want it to find. So let's say I want it to find academy. So basically, I want to check to see if the
okay, so it's got to be in quotes too. So we're looking for the quotation red.
word academy is inside of this phrase string up here. The next argument I want to give this, the next parameter, is going to be an integer, and it's going to be the index where I want to start looking. So if I wanted to just check to see if it was in the string, I could say 0. If I wanted to check to see if academy occurred after the third index, then I could say 3. Let's just say 0. So now this is actually going to give us back a number, and it'll tell me at what index position inside of this string academy occurs. So
Oh, okay. So this will say where, at what character position the phrase red starts, I assume. So it should be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it might put out 11. Let's run this. Puts out 10. Okay, so it follows directly the 10th line. No, I'm dumb again. I'm counting from 1. I should be counting from 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this is 10.
So now I'm going to run my program. You'll see over here it's giving us an 8 back. That's because academy starts at index position 0, 1, 2, 3, 4, 5, 6, 7, 8. So academy starts at index position 8, and that's why it gave that back to us. So I could do this with anything. I could say like FFE or something, and now this will tell me where FFE starts inside of this string. So it starts at index position 4. So that can be pretty useful, and it's a really useful way to figure out if different things or different strings show up in the string you're working with. There's one more string function that I want to show you guys, which is called substring. So it's just phrase.substr, and this is also going to take 2 parameters. So we're going to give this 2 pieces of information. The first piece of information we're going to give this is a starting index. Now, substring allows us to take, just part of this string. So I could specify that I want to take like all the characters after this A, or I could specify that I wanted to take like from index position 1 all the way to the end. Basically, it'll allow me to take like just a subsection of this string. So the first parameter I want to give this is a starting index. So I could say like 8. And so basically, this is going to start grabbing a new string at index position 8. Then I can give this a length, and this is basically going to tell substring how many characters I want to grab. So if I said like 3, this is basically going to start at index position 8. So it's going to start up here at this A, and it's going to grab 3 characters. So it's going to grab this A, this C, and this A. So now when I print this out, you'll see we get ACA just.
Okay, so if mine starts at 8, which is, this is 5, 6, 7, 8, it'll start here and grab 3, so it should be space RE. Whoa. Why is it backwards? 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's grabbing 8. Not after 8. It's on 8. It's grabbing E space R. That's what it's grabbing. And then that's what shows up here. Okay.
Just like that. And that's basically what we do. So this is the start.
So if I start at 5, which is A, and do 3, it should be R. A-R-E. Is my math just really this bad right now? I literally just guessed 28 is half of 1.5 times of 42, but I can't get this. 0, 1, 2, 3, 4, 5. Starting at 5, which is the space. I keep going after it. Build and run. ARE. We start at 0 and we grab 5 characters. It should be roses. Okay. And this is what did he call it?
Starting index,
Substrate?
this is the length. And one of the cool things we could do is we could actually take this and store this substring in another string. So I could say like string phrase sub, just like that. And then I could come down here and I could say phrase sub is equal to and then what we just had before. So phrase dot sub string. And now if we print it out,
Substring. Phrase.substring. And then colon, and I had So if that's 0, that's 4, 5, 6, 7, 8, 9. On 10, grab 3. End the line. And then down here we write phrase sub.
Out phrase sub, it'll print out ACA. So I'm essentially storing the value of the substring in
And it should
another
print out
string.
red for me. Nice. I'm learning. So this is, we're denoting a string phrase. Denoting a string as the name phrase. Roses are red. Then we're denoting a string phrase sub, and we can do that on a separate line. Then phrase sub is equal to the phrase with the substring starting at position 10 for 3 characters, and then we're printing or outputting or whatever that is, printing phrase sub, which is denoted here as this. Okay.
So that can be pretty useful. And that's really the basics of working with strings. I mean, obviously there's certain things that I left out. I could spend an hour just talking about all the different things we could do with strings, but I think that kind of covers the basics, kind of shows you all the basic things that you can do. We looked at some basic functions. We talked about grabbing individual characters. We talked about string indexes. So I think for now, that should be a good introduction into working with strings in C++.
Okay, numbers are next. Let's see. Numbers are quite long. So I'll do numbers. Okay, so new project console. And this one's going to be working with numbers. Finish. Open main. Get rid of this line. Put a bunch of empty space. Save. Ooh. Oh, that was open. Oops. Okay, we'll get through working with numbers, and that'll be what we take on for now. Need to take a little break, maybe get some breakfast. I don't want to overdo myself, you know. I mean, this is literally 4-hour tutorial that I'm watching at 1.5 speed. I want time to absorb some of this information. And I did read recently, this is kind of a tangent, that watching something twice as fast, if we put this on 2 times speed, and retaining 70% of it, as long as you're retaining more than 50% of what's being said, then watching it a second time, still at 60% speed, or 2 times speed or whatever, is more beneficial than watching it at normal speed only once. I understand that. It's like repetition. And you get to hear it twice. Because, let's be honest, even if you're watching at 100% speed, you're not internalizing 100% of it, right? It's more like 80 or 90. And so if you can get 60% at double speed, and you can even slow it down too, like you can pause it and stop. And so I watch most videos at 2 times speed that are like guide based and not entertainment. Anyway, tangents over. Let's work with numbers.
In this tutorial, I'm going to talk to you guys about working with numbers in C. Now, whenever you're writing programs in C, one of the most common types of data that you're going to be dealing with are going to be numbers. So these could be things like whole numbers or decimal numbers. Basically, I'm going to give you guys a full overview of how to work with numbers. We'll talk about the basics. We'll look at how we can use different mathematical functions in order to do different mathematical operations with a number. So this is going to be a pretty cool tutorial. Now, down here, I'm just going to talk to you guys about the basics. There's really 2 types of numbers in C that we deal with: whole numbers and decimal numbers. And whole numbers are basically referred to as integers, and decimal numbers can be referred to as 2 things, either floats or doubles. And essentially, the only thing you need to know about that as a beginner is that doubles allow you to store more specific decimal points. So with a double, you can store, potentially more decimal points than you could in a float. And there's more differences, but if you want to get more into that, you can kind of look it up. But the basics of using numbers is you just type them out. So if I wanted to, for example, print out the number 40, you see I have a C out here, I can just type it in and we can print it out, we can work with it. In addition to positive numbers, we could use negative numbers. If I wanted, I can make this a decimal. So really, numbers are very simple. You just kind of type out the number. But we can of using numbers is you just type them out. So if I wanted to, for example, print out the number 40, you see I have a C out here, I can just type it in and we can print it out, we can work with it. In addition to
Really? Mine won't let me print it. I fuck something up already? Int main. C out space, double brackets, 40, colon return 0. Why can't I build this? I literally have no clue what the fuck is happening. Let's just get rid of this whole string. Here. $40, colon. I can't build anything. What? I can't build this one. Oh, I'm so dumb. I have this open. Oh my god. I'm gonna hit double M so much while I'm learning this muscle memory for this. 40, okay. Now we build. What's out 40? Okay.
Positive numbers, we could use negative numbers. If I wanted, I can make this a decimal. So really, numbers are very simple. You just kind of type out the number. But we can also do things like math. So for example, I could say like 5 plus 7. And in addition to printing out 5 and 7, this is actually going to do this math operation. So this will actually print out the result of 5 plus 7. So you can see we get 12 over here. So we can use addition. We can also use subtraction.
Okay, let's see. 5 plus 7. 1. 12.
We could use division, which is going to be this forward slash, and we could use multiplication, which is going to be this asterisk. So if I was to multiply these two numbers, now you see over here we get 35.
Okay, so just the stuff that's on the numpad probably. So there's addition, subtraction, multiplication is this, the asterisk. It's not an X. You do X in middle school, but that's not what it is. Asterisk and division. Okay, so 5 divided by 7. Run that. That's 0. I mean, I don't think that's right. Pretty sure it's not actually.
So those are the 4 basic math, operations. So that's gonna work really well. Also, one other thing I want to show you guys, which is called the modulus operator. And the modulus operator will basically give us the remainder of dividing two numbers. So if I said like 10, and then
All right, modulus operator.
made this percent sign, and actually this is read 10 mod, and then I said 3. So we read this 10 mod 3. What this is gonna do is it's gonna take 10 divided by 3, and then it's gonna give us the remainder. So this modulus operator will give us the
Modulus operator. So it's okay. So 10% 3. 10 divided by 3 and give the remainder. So let's do it in a calculator first, and just because I want to see like what's happening. So 10 divided by 3. So the remainder would be a third. I don't know.
remainder. So 10 divided by 3 is gonna be 3 with a remainder of 1. So now we should just get 1. And you can see over here we get 1.
Okay, I don't understand that math at all. What? 10 divided by 3 is 3. And then is it the whole number remainder? Let's find out. Let's do 12 divided by 3. That'll give us 4 with no remainder. So will it come back 0? Run this. Gives us 1. It's probably rounding. I would just assume that it's rounding to a whole number. We do 12. It gives us 0. Okay. So it's probably just rounding. I could be wrong, but fuck me. I'm really congested this morning. I'm not used to talking this much.
So sometimes that modulus operator can come in handy. We can also represent order of operations in C. So C is going to adhere to like the normal order of operations, like P, E, D, M, S, I think it is. Please excuse my dear Aunt Sally. Basically, like multiplication and division are going to come before addition and subtraction. So if I said, for example, like 4 plus 5 times 10, this is going to do 5 times 10 first. So it's going to be 50 plus 4. So we get 54. But if I wanted to do the addition first, I could just put parentheses around this. So now it's going to do 5 plus 4, 9 times 10. So now we should get 90.
Okay, so it's just doing math functions. Okay, so I like these. Let's come up with a hard one. We'll do 25 plus 9 times, oh, I need spaces just to make it neat. 25 plus 9 times 2. So it should be 18 plus 25, which is what, 38? Or 8, no, 18 plus 5 would be 43. Yeah, 43. Okay, cool. And then if we put divided by 2, I assume it'll do 9 times 2, 18 divided by 2 is 9. And then this would be 36, 34. 34. Cool.
And you can see what you do. So if you need to separate order of operations, I mean, it's essentially just following basic math order of operations rules, but you could represent those like that. So in addition to doing all that stuff and just printing out numbers, we can store numbers inside of variables. So I can make an int, we'll just call it like wnum for whole number, and we'll just make this.
Okay. Let's get rid of this. This is the print area. We're gonna do tab. Oops, what did I type? Oh, tilde, I don't want tilde. Okay, so we're gonna do an integer. Or an int variable, whatever that means. Whole number equals 5. End line, or colon.
It's 5. I can also use like a double, and this will be like dnum for decimal number, and this will
Okay. I'm gonna do a double. Dnum, which is decimal number, equals 5.9.
be like 5.5, right? I mean, now we're storing these numbers inside of variables. If I wanted, I could just print them out naturally like we did down here. I want to show you guys one cool thing we can do though, which is incrementing.
Okay, and then we can print out a whole number by doing that. So that should just print out the 5, I think, right? Well, that didn't work. See out whole num colon.
A number that's stored in a variable. So I could say like wnum, and I could say plus plus, and what this is going to do is it's going to add 1 onto wnum. So now when we print out wnum, instead of just being 5, it's going to be 6 because we're adding 1 to it. So you can see we get 6.
Oh no. Okay. A bad feeling. Plus plus colon. Integer. Did I need parentheses or something? Let's delete the whole thing. Start over. Int wnum equals whole number equals 5 colon double dnum equals 5.5 semicolon wnum plus plus colon cout double brackets wnum and then colon. It worked that time, so I must have just had a typo or something.
And that's a shorthand that'll come in handy a lot. There's a lot of situations where you want to increment a value. You could also do like minus minus, and that will subtract 1 from it. You could also do like wnum plus equals, and we could say like 80. And so what this is going to do is it's going to take wnum and it's going to add 80 to it. So now we should get 80.
Plus equals. Okay. I'm following. So it's saying you take the integer double num, wnum, take the integer whole number that we designated as 5. And we're going to do the function of addition. And then we want that addition to be equal to 80. If there's a space there, I don't know. It shouldn't fuck it up, but we'll see. Looks like it does fuck it up. Okay, so if we backspace, it should be 85. Yeah, 85. Okay, so it does have to be combined. Okay.
85, and you see what we do. You can do plus equals, multiplication equals, minus equals. I think you can do division equals, and all of that will It's basically shorthand, so you don't have to type out all that stuff. So now that we kind of looked at all the different operators, let's talk about how decimal numbers and integers work together. So here's a little experiment. Let's say I came down here and I added 5.5 plus 9. So I'm adding a decimal number, and I'm adding it to a integer number, right? So let's see what happens. Over here, you'll see that we're going to get a decimal number back. So anytime we're doing math between a decimal number, like a double or a float, and an integer, a whole number, we're always going to get a decimal number back. So it's always going to give us the decimal back. But it's important to know, though, if I did math with two integers, so for example, let me show you guys, if I was to say like 10 divided by 3, and these are both integers, keep in mind, I'm actually going to get an integer number back. So we're going to get like 3 back because that's technically the answer. But here's the thing, this isn't actually the answer. Really what it is it's 3 with a remainder of 1. But because we did the math with two integers, we're going to get an integer value back.
Okay. So if we do the math with 3 or with integers only, we get integers. If we do it with doubles, then we get doubles. I don't know how requisite it is to put spaces everywhere, so I'm kind of just following it exactly at the moment. Gives 3, which is not correct. What if I do 10 point, like 4 zeros? Okay, so I did 10.1234 zeros, and it gave me 3.1234 characters. Which I don't understand. Why is it 1 less? Or 1 more? I make it, let's go down actually. If I make it 3, will it be 4? Build 2, 3, 4, 5. No. If it's 10.0, it is still 5. Okay.
If I was to make one of these a decimal number, or even if I made both of them a decimal number, now we're going to get back the actual like full answer. So it's going to be 3 with 3 repeated, just like that. So you can see if we do math between just two integers, we're always getting an integer back, even if that's not like fully the correct answer. And in different circumstances, you're going to want to do that. In other circumstances, you're not.
Okay, so let's try something else. 5 divided by 2 should give us 2.5. If I put 0.0 divided by 2, it'll give us the full 2.5. And if I do divided by 3, okay, so it's just giving me 5 digits even though there's more. Okay. All right.
But just keep that in mind. So that's kind of how integers and decimal numbers interact with each other. So now what I want to do is show you guys how we can use different math operations. So generally just with math, there's all sorts of different, operations. You can do like square root, you can take a number to a power, we can round a number. And in C, there's actually these things called functions, which can do all that stuff for us. A function is basically just a collection of code that we can call that will perform a specific task. And we're going to talk more about functions later. But for now, I'm going to show you some basic math functions that we can use. In order to use these math functions, I actually have to do something called importing them. And essentially when we import something, we're telling C++ that we need to go out and grab code from other files. So up here you can see we're using this include statement and we're grabbing something called IOStream. I'm going to add another line here. We're just going to put a hashtag. We're basically just going to copy this guy up here. I'm making open and closed greater than less than sign. And in here, I just want to type in C math. And basically what this is going to do is it's going to tell our C++ program that we want to use some math functions. That's kind of all you need to know at this point. Just know that you need to put this up here in order to follow along with what I'm going to be doing. So down here, we can now use a bunch of different math functions, essentially just math operations. So for example, I could say like POW, and what this will do is it'll take 2 arguments. So in here, I could pass 2 numbers, like I could pass a 2, and I could pass a 5. And what this will do is it'll take 2 raised to the power of 5, and it's just going to print that out. So when I run my program, you'll see we're getting 32. So 32 is 2 raised to the 5th power. And you can kind of do that with any number. So I could also say like 3 raised to the 3rd power, so 3 cubed, and now we should get 27, which we do. So that POW function can be pretty useful. There's another one, square root, SQRT, essentially doing the opposite. So we could say like square root 36, and now this is going to give us the square root of 36 back, which is going to be 6. So that can be pretty useful. And inside of these functions, you can put decimal numbers too. So I can put both integers, like whole numbers, and also decimal numbers. There's another one which is called round, which is going to round a number. So if I put like 4.3 inside of here, this will return
square root 3. Okay. And if we do, we also put in round. .9. Return 6. 5.5. What does 5.5 return? 6. And 5.4, I assume, rounds down. Regular math. Okay.
The rounded number. So you see we just get 4. And this will follow normal rounding rules. So if I change this to 4.6, now we should get 5 back. There's a couple other of these functions which will similarly like round decimal numbers. I can say CEIL. And what this will do is it'll automatically just round the number up.
CEIL will just always round up. Okay. Let's try. Rounds to 6 even though it's 5.4. 5.1. Rounds to 6. Okay.
So even if this was like 4.1, this will round the number up to the next highest whole number. So you'll see here we get 5. You can do the opposite, which is floor. So if I could just say floor here, if I put a 4.8.
Oh, ceiling. These are things I wish that he explained. Like, why do these particular lines of text mean anything? Why is this name important? What does C out stand for? Floor now makes sense with ceiling. CEIL. It'll round it lower. I guess these are things that I could figure out anyway. Should drop it to 6 as well. Yeah.
In here. Normally it was supposed to round up, but now it's going to round down because we're using that seal or that floor function. So those can be pretty useful. And there's one more I want to show you guys, which is called fmax. And fmax is going to take 2 numbers, so I can pass in like a 3 and a 10. And this will tell me which one's bigger. So this will return back to us the bigger of the 2 numbers. So now we're on
the fmax. So if we have 10 and 3, 10 and 4, bring back 10. Yep. 10 and 40, bring back 40.
On this program, you see it's giving us a 10 back because 10 was the bigger number. And a lot of circumstances in C, you're going to have 2 numbers. You might not know which one is bigger, so this can be really useful to tell us. And you can also use fmin, which will do the opposite. So this will tell us what the smallest number.
Fmin, okay. Okay.
Number that we passed in was, and you can see we get 3 over here. So those are some basic math functions. There's a lot more. If you just go online and search C++ math functions, like you'll find a huge listing of all of them that you can use. There's things to do.
Let's do it. Can't even spell right. Holy crap. Chrome capture. Okay, can I copy this? Yep, and then paste. Oops. Okay. You look at these math functions, W3 schools. Highest value of X and Y. 5, 10 should return 10. In should return 5. Okay. Functions, square root, round a whole number, natural logarithm, CMath header file. Okay, other math functions, absolutes, arc cosine, arcsine, arctangent, cube root. Wow, yeah, you can do a lot. Okay. Hyperbolic tangent. Okay, this is even more math than I know, but okay. This is a cool website though, W3 Schools. I'll save this. All right. Bring him back
like
up.
sine, cosine, tangent. You can do like logarithmic stuff. You can use like exponentials, all different stuff like that. It can be really useful. But that's kind of the basics of how you can use that. And really, numbers are extremely useful, and that's kind of been like a broad overview of sort of all the stuff you can do with them.
Okay, so the next section will be generating user input, but this is where I'm going to sign off. We are almost exactly an hour into this video, which is pretty cool. We've been watching it on double speed. I need to save this video much later. Okay. So that's the first live stream of this. I'll be doing it again maybe later today. This is about an hour and a half, which is about the length of pretty much the length of a college class. So learning this in an hour and a half is pretty cool. I feel confident enough to know how to do math functions, how to create some very basic variables, text, strings. What else did we learn? Different phrases, and then so you can denote strings as a phrase, and then you can type out the phrase. You can find where something is in the phrase. This one, that's kind of cool. We learned about character. So you can denote a character as whatever you wanted to denote it as, and then what it actually is. String phrase, integers, doubles, which are decimal point integers. And there's also one other one that he mentioned that I don't even remember. Go back a little bit. Nah, it's fine. I'll do it later. And Boolean, which is true false statements. So that's cool. So what happens if I do curious 4? So it should do if I do bool. Or whatever. It's looking for grade, which is this, which is A. It's fine. Okay, so that was a pretty successful day then. Pretty successful first class. Going through this C++ tutorial for beginners. Mildly interesting. The beginning part is always kind of a slog, so yeah. Hope you guys enjoyed. I'll be doing this maybe later today. We'll see how my mental state holds up. Like, I haven't been doing school stuff or learning in a while, so keeping my focus for that long and actually retaining the information might take some time to build up, as it should. You can't just go into pulling all-nighters for an exam when you've never done it before, like 2 nights before. You won't do well. First-hand experience. So I hope you guys enjoyed, and